if you refer to this sheet, what you'll see here is, now this isn't a very good picture here, show and tell. But what you'll notice on the sheet is on the left-hand side is a picture of how this particular part was made without 3D printing. The backstory on this part is it's actually a part, if you look on the right, this looks like a manifold or something, I don't know the name of the part. This is a part out of HP's upcoming 3D printer. And our upper management said to the design staff as they were rolling out the printer, hey, how many parts are we 3D printing for manufactured inside this printer? And we said X. He goes, that's it? He said, it should be like 3X. He said, go back and try again. Okay, but you know what? HP is a pretty responsible company to our supply chain and manufacturing. They said, we're only going to be able to 3D print for manufacturer if it makes financial sense. Let's find a way to make it financial sense. So we said, okay, we have a bunch of designers. We're 3D print like champions, right? We went to the designers and said, well, why don't we 3D print these? We did the cost analysis and said, there's 5 parts making this manifold, and after we make the 5 parts in injection molds, we cut 5 molds, print 5 pieces, use a person to assemble those pieces, and now you have a part. And then after we did the analysis, we said that doesn't make financial sense to 3D print. Oh, well, why are we designing it that way? Because if you 3D print, you don't have to make 5 parts. You can actually consolidate and make 1 part. But there's a different set of design rules. And that's when we realized that even our own designers hadn't really been taught yet how to do design for additive manufacturing. Now I'm going to start using the term additive manufacturing instead of 3D printing. It really goes more towards that making end-use stuff, right? So we took one of our experts on the 3D print team, had him spend a couple of days with design engineers and taught them how to redesign this for additive manufacturing. And now, this particular part, instead of being produced out of 5 molds with 5 pieces, assembled and then a 6th piece inserted, and having all that labor cost, and produced wherever the molds are, now this is printed in 1 piece. It's incredibly complex, and if you're familiar with manufacturing, this is nearly impossible. Well, it is impossible in a mold, right? But in 3D print, you can do it. And guess what? Once you have the intellectual property and all that stuff created, you can print it anywhere in the world you have that same digital output or additive manufacturing technology deployed. So now you can regionalize it. And you're not having to go through some of the supply chain issues such as ocean freight and burning the fossil fuels to get the parts to you. So you can really change how supply chain works. This is the cool part about 3D printing. Yeah, complexity, but yeah, it's going to change where you can make stuff, and it changes a lot of other downstream things. That's what we talk about in the additive manufacturing. So we've asked these panelists to come here because there's challenges and there's successes. And one of the challenges in HP was we need to teach our designers how to think different. We need to teach them how to leverage this new tool called 3D printing so they can leverage all those downstream benefits. But we need to grow that bigger. And I think about 100 years ago when the auto industry was in the second industrial revolution, right? And where did the auto industry in America end up? Kind of all in the same place. Why? Because a lot of the resources were in that same place. Some of them were human resources, some of them were other resources. And then you think, well, the OEMs, they needed, I want to start a new car company. So what they do, I need somebody who knows how to make cars. What they do, they go and hire from their competitor. Then later their competitor comes and hires that person back, right? So you have this small pool of talent to work with. And eventually, if you want to grow the industry, you need to do 2 things, at least 2 things. But one is grow the talent pool to make better product, and the other is teach people to use a product that never existed. Before the auto industry, it was horse and buggy. And the interesting thing that we have a challenge and opportunity in front of us is like when you switch from horse and buggy to automobile, we need an ecosystem. When you put an automobile on a horse and buggy way, a little dirt pathway, there was no traffic lights, there was no rules of driving. Now you give somebody something with a few horsepower and they can just drive easily. They bump into each other, they don't know what side of the road to ride on, right? They don't know when to stop to let the other guys go by. So we had to come up with policies, we had to come up with rules so that they could actually use this new technology. So in a way, we have to do that now with additive manufacturing. And this, to me, this is the exciting thing. Enabling the future workforce, help change their way of design, give the current workforce a pathway to get involved in 3D printing, and then come up with policies and things which help benefit and let it grow. So we have some really great panelists with us today. And I I'm going to start by asking these panelists, and we'll start with President James Tressel of Youngstown State. What are you doing with 3D printing at Youngstown State today?
Well, it's really exciting to see the age of this crowd, just so you know, because a lot of these young people here are going to say when they're our age, they're going to be talking to the people that are now their age, and they're going to say, you mean you used to take material and chop it up and put it in molds? And kind of like they say to us, you mean you had telephones that had wires coming out of them? And so it's really neat to see that this group of people who are going to be able to really take the message about the importance of 3D printing. And what's been so exciting for us at Youngstown State is that we kind of lived by the thought that there's no such thing as now. You're either early or you're late. And we've been fortunate through Congressman Ryan, America Makes, our faculty who have been involved in additive manufacturing for a long time, but really, who have really jumped on board to take it to the next level and to be early and to not kind of do it afterwards, after someone has already taken the market, taken the manufacturing to their country or to whatever. And so probably the biggest thing 3D printing, additive manufacturing has done for our campus is it's given us a chance to recruit extraordinary faculty. We have some faculty involved in this space that are world renowned. We were over in Israel at the Technion, and Technion is like MIT is to the United States, and we're sitting there talking with their faculty, and all of a sudden they raised up when they saw what our faculty were working on, the things that they were thinking about. And all of a sudden our faculty are over speaking to a global conference this past May at the Technion with a couple of the world-renowned faculty from Israel. And 2 years from now, that global conference will be in Youngstown, Ohio. So what it's done by having America Makes be in Ohio, much thanks to Congressman Ryan and the leaders here in Washington, they saw fit that that would be a great place for it to be. And to bring guys like Rob and his people.
about 40 miles up the road. And we are a manufacturer of mostly defense aerospace castings. So we melt metal, and we pour molten metal into molds made out of sand, and we make parts for those Navy programs, Air Force programs that are legacy, that are 50, 60 years old. We make spare parts for all flight platforms, tanks, ships, submarines, and these small parts are also in small quantities. So we talk about one replacement to 10 pieces. And our business is sort of the poster child of the foundry and putting merging those together. Let me explain to you why. So we have 7 smokestacks, and thanks to 3D printing, thanks to Additive, those smokestacks are smoking today, clean smoke, clean smoke, because of the Additive. So we got involved with Additive 3D printing because of a workforce situation. My company is 98 years old. Got started in 1920. In fact, coincidentally, my grandfather worked a couple blocks down the road here during World War I. 1918 to 1919, he worked at the Washington Navy Yard. He was a tool maker there. He was one of the tens of thousands that helped with the war effort of making ship guns, armaments, and gearboxes for the Navy ships and the Navy ships. So after the war was over, he came to Baltimore and started his business in 1920. So our business is steeped in trades, tool and die making, machining, handcraft skills. Our last apprenticeship graduated in 1996. So if that's not writing on the wall for industry, I don't know what is. Without tool and die makers, industry is like a farmer without shovels, or a miner without hoes, or a fisherman without fish hooks. So we had a real crisis. And what we decided to do was adopt additive manufacturing, get a large 3D printer to replace all the tool and die makers that are retired to make the tools and dies. So we're not making parts for the airports that are 3D printed with metal or plastic. We're making tools and fixtures to make those parts for airplanes. Now, since the last 10 years, thanks to Additive, we've become Maryland's largest small business defense contractor. We have about 65 employees. We're in Northwest Baltimore City. We're hub zone also. We're in a really challenging, very violent neighborhood. And we've been able to win defense contracts because we're the low bidder. So the good news about defense, the bad news about defense is that you're the low bidder when you win defense contracts. And we've been able to win contracts for legacy parts that are 50, 60 years old. For not only the part, but you have to provide all the jigs and fixtures and tooling to make that part. So for example, if somebody has a tool and die that they have from 1960, they're going to be thinking they're sitting pretty because they have all the equipment to make the part. Danko is winning those contracts for legacy parts in small quantities of 5, 10 pieces with new tooling. We're the low bidder, and we got all the extras to make that tool and die. That's really remarkable to be that transformative and use this technology. Secondly, we're in a challenging neighborhood. We have a lot of violence in Northwest Baltimore City. We have a hard time attracting talent because of our neighborhood. But the good news is, nights and weekends, we are 3D printing, and we're making product with nobody there. All we need is electricity, and we need enough material to print through the weekend. So that's really transformative for our industry as well. So for us, it's a workforce issue. It's a big nut, expensive tooling, expensive equipment to maintain, but it creates jobs for our hub zone. We're creating jobs for grinders and molders. 1/3 of my company is ex-vendors. So we hire our neighbors right here in Baltimore City, and we put them to work. So 3D printing is not taking somebody else's job. It's promoting jobs. It's actually growing the company. We're expanding. And working right now with Baltimore City and apprenticeship programs. We're trying to come up with the first additive apprenticeship program in Maryland for teaching this technology to not only grads from universities like Youngstown, Johns Hopkins, but also somebody who's graduating from high school, Baltimore Robotics, middle school kids. So it's completely transformative for an old-fashioned, 100-year-old business that's got smokestacks that are smoky today thanks to this incredible technology.
Let's go back, President Tressel. So
I want to say we hear, but I don't know what you guys hear, so I'll say I hear often, that there are different viewpoints, maybe conflicting information around talent gaps in new technology. I mean, I like to promote that I think we need a lot more information, a lot more training, et cetera, but that's maybe my viewpoint. But there's conflicting information on that. So that involves probably any kind of, any area of education today. It's actually kind of interesting, but certainly for 3D printing. Could you talk about any challenges you see in that area, or what you guys might be doing it, or how we could overcome any gaps, or maybe if you've already done it, what kind of programs exist that have already helped kind of bridge that gap?
I think the key to getting anyone involved in something is to have them exposed to it, understand it, and see the opportunity there. And as Congressman Ryan was talking about, this innovation center concept that we have, that is getting people from the career and tech centers, the high schools, the community colleges, the people from manufacturing who are trying to solve some of their problems, getting them all in the same space, talking about things, talking about the opportunities. And what we found at the university is now with 3D printing, additive manufacturing, it's beyond just our engineers. Now our art majors are going to our launch spaces, our maker spaces, to create the things that you used to need a machine for, or an injection mold for. But now they can create some artistic things with different designs that have, like you talked about with the lattice, the difference in weight and so forth. They can create so many different things. So now the interaction is beyond just that person who thought they wanted to look into engineering or liked being involved in technology. We're finding the more we put them together and give them actual project type things to do. We have one example. There's a Valoric Steel, which thanks to the Congressman, we had a chance to move a steel company back in to the area, and they're making a lot of piping and so forth for the natural gas boom. And they had two of our students come in for a capstone project, and they said, we have this problem. And our students were able to create the solution to the problem and save them $1 million, because they had been around America Makes, they'd been around our faculty with research, they'd been around problem solving. It was bigger than just what they'd been a part of before. So exposing them to those real life things, exposing young people to, hey, here's where the world's going, here's what you need to start thinking about so that you're early and you're not late. We found that our students really enjoy it, and it's been able to attract more students. Our enrollment's gone up dramatically in our STEM fields because of additive manufacturing.
Do you think there's an opportunity to expand that kind of activity, those kind of programs nationally, to get a bigger foothold for this industry and for all the benefits I talked about earlier?
Yeah, I think the Whisper campaign is the most important one, which a lot of you represent a lot of different states and constituencies and that kind of thing. If the word gets out as to the importance of this for the future of our country, the future of our economic prosperity, and then we get some funding out there to create ecosystems like we're trying to create with America Makes and all the rest, that's going to be important. That's why we wanted this room full of people to grow in a deeper understanding of what's our opportunity with this manufacturing of the future.
Okay, thank you for that. And that wasn't one of the questions I told you earlier, but I like your answer. Just to give you an idea, we have a report that's available, and you can sign up and we can email to you. We don't have them on print here, it's kind of long, but it was done by E.T. Kearney. And they did some analysis on the future of manufacturing job growth in America, and largely due to about at least 20% annual growth, let's say, contributed largely to 3D printing in that manufacturing sector. There could be an increase of as much as 3 to 5 million jobs in this country. 3 to 5 million jobs. And that's over, let's say, 5 to 10 years, okay? So it's a good time horizon. But that applies to not just technical people and how to design that part. It applies to finance people, sales and marketing people to bring these products and this technology out. It involves engineers, operations people, administration, they all need some level of knowledge to be able to move this forward and take advantage of those knock-on effects that 3D printing can bring. So if you're interested in that report, by the way, just ask us. Kasia can help get it to you. So we'll go to Ben. How about same question to you about the challenges and the opportunities?
Yeah. So when I think what we need to do to train the Department of Navy workforce in this technology, I like to break the workforce up into different subsets, right? So we have the acquisition community, those folks are in charge of buying the next ship or airplane or Humvee, and they know a certain amount of information. We have the technicians and the depot and shipyard workers, and they need to know how to run machines themselves. And then we have the warfighter, the sailors and marines who we deploy equipment with, need to know how to run the equipment at the point of need, right? So today, you asked what training exists. We've deployed introductory training, right? We've deployed several 3D printers. We have Marines and sailors have been trained to use them, and we're seeing huge returns on that investment, right? They're making things that are helping the mission while they're deployed. Here's the biggest challenge is we're paying to train these folks the best that we know how. But when they get out of the service, there's no certification, there's nothing recognized by industry that shows they've proven they have those skills. So when we train chefs in the Navy, we send them to culinary from America, they get these certifications, so when they get out of the service, they're marketable, right? There's a huge need for this skill set in industry. So what we need to do and what we're working, and I think Rob's here from America Makes, and this is one of those cases where, if you're not familiar with America Makes, they have just under 200 now industry members. Over 200 industry members. And several government agencies, federal agencies as partners, so they're in a good place to come up with what the requirements are that will be recognized by industry that we can teach, our sailors, our Marines, or airmen or soldiers or sister services, right? So I think that's the biggest challenge or gap I see right now, something that we're working on really hard so that we can put those things into place.
Awesome, thank you. And keep in mind, we're gonna invite you to ask questions here in about 10 minutes. So if you got some questions, table them, be ready, right? So John, same question to you. Challenges, how could you keep that going or even think about other businesses? Because there's a lot of small businesses like yourself in this country that are really driving our economy. And speak for them too a bit. What are some challenges for you and potentially them? I know you've met a lot of them at the big additive conferences and stuff.
So I think the biggest obstacle we have, the barrier right now moving forward, is awareness. So we think of 3D printing, we think of Sky Mall, make a box, or we think of making something for your house or your kids making a little sculpture. There's a huge awareness issue of what this additive can do for industry. And I think what we need to do in this country is open up our factory doors to our communities and have open houses. I think middle schoolers come over. I think we have more STEM, Boy Scouts. We have University of Maryland come to Danko, Arlington. Johns Hopkins University does their Baja car. They get designing the parts on CAD. They come over and they make the parts at the company. So we're trying to do this grassroots level in Maryland, in Baltimore, because Maryland's not a manufacturing state. 4% of Maryland's economy is manufacturing. That's it. Unlike Ohio, which is a manufacturing wannabe for us, and it's a desert. So we have to start from the very beginning. So we're starting with young people, and you can go into community colleges and speaking. I know that's not hard. That's not easy for business owners to do, but open houses and networking, just like we're doing right here. We became a large defense contractor because we hosted the Defense Logistics Agency in Richmond, Virginia, our company for bus tour for a number of years. And so we educated all the engineers, and they thought, wow, we could use some of this. And that's how we got started with them, all working out. So networking is really, really important. America Makes. We're also a member of the National Association of Manufacturers. So we're trying to work through NAM and America Makes and our community to get the awareness out. Manufacturing is cool. It's techy. It's you got to be right. And there's a misnomer in our country that you have one eye or two fingers and you're working in a cave. That's not the situation in 2018. So we got to go with awareness. And next is apprenticeship training. So as I mentioned, we're working with MEP Maryland, come up with an additive manufacturing apprenticeship program. And we're also coming together with University of Maryland, Howard Community College, and Baltimore City Community College to try to get some related arts. Tooling U, SME Tooling U. We're trying to work with Becky Kemp and MEP for getting a program. So like Ben said, we want a certification you have committed so many hours. And by the way, tool and die making at our company, our apprenticeships go back to 1940. The FDR administration first came out with apprenticeships. We have one of the first in Maryland. 10,000 hours, 5 years. You can go and get a liberal arts degree or bachelor of science in 4 or less, but it's 10,000 hours. That's a lot of time. So we need to work on reducing the apprenticeship and related arts training and getting better awareness.
If I could just add, we have a piece of legislation we're trying to push that we can get to all of you and get to your bosses on creating what we're kind of conceptualizing the shop class 2.0. We got rid of a lot of the shop classes over the years, and so we want to help schools add, develop, have 3D printers, get people engaged, get kids engaged, teachers trained up to be able to understand this stuff in an early age. So as you're going through the process, this becomes second nature, so that you could maybe even get credits at some point for apprenticeships, and you can start to streamline some of what you're talking about. But I think having a federal role, given the federal need through the Department of Defense and the opportunity for 3 to 5 million jobs, I think there's a responsibility for us to make some strategic investments into our schools who otherwise may not know about it, wish for campaign, keep raising awareness, but also may not have the funds to go out and fill a classroom full of 3D printers.
Thank you. That brought back a really neat memory, and it ties into him. When I was in shop class in high school in Northwest Pennsylvania,
I want to hear how this ties back to him. That would be interesting.
I learned how to sandcast. We had a foundry inside our shop, and they taught us how to make a pattern. I made a dog face, and sandcast an aluminum dog head, and painted the eyes in later. But I learned what sandcasting was all about, and so now in 3D printing, I've never been in an industrial sandcasting application, but I get it. And so that actually helped me, those shop classes, understand what I do today, weirdly. And those were only, half-year classes that I did, probably at wood shop, metal shop, or whatever. I agree with you. I think those are really valuable.
Well, the good news is what Congressman, what Tim was saying is that unlike other professions, we don't have a retention issue with 3D printing. It's not like you're going to train somebody and they're going to leave and go to a lesser job. They're going to might get another job, which is going to get them more money. But 3D printing is sexy. It's desired by kids, young people that do games, robotics. It's not going away. Everybody wants to get into it. So you're not going to have an issue where people are going to drop out. They're just going to get more and more talented and produce more and more for our economy.
I think a spinoff, I'm not supposed to talk here. I'm a congressman, so just like I'm not a senator, never let anyone else talk. But to be able to talk about the ideas that spin out of these new industries that will come. So there's some studies that are out there saying there's going to be like 100,000 niche industries, for printing things, certain kinds of shoes and certain kinds of this and that. But then with eBay, you're going to sell it to a global marketplace. So the idea here is we educate our kids. Yeah, some are going to go work for other companies, but then some are going to sort of come out of the military and think about, okay, what can I do in Youngstown, Ohio, or Akron, Ohio, wherever, and start a company? And maybe only have 4 or 5 people working for me. But as you're seeing what's happening in the new economy, you're talking about startups, which is the best opportunity for job growth in the entire country. And it's been stagnant, and I think this is an opportunity to create and bring wealth to communities that have seen the erosion of wealth in private investment because of the erosion of manufacturing. So it all kind of ties together, and it's got to be creating that pipeline for industry, but also for entrepreneurship.
That's an excellent point. I can't agree with you more. I think that's an awesome vision. So let's go back to President Tressel. So again, each of you listen carefully to this question. Listen carefully. That's pretty easy. So you represent education, so academia, government, and business. So how are those three generally, not you three, but generally working together? Now it's been touched on a little bit already in our discussion, but how can those three work closer to address any workforce issues, and how can you be complementing each other? And then is there something people in this room could influence that could help?
The concept that we put together with our innovation center, where we have brought together this ecosystem, where we have our governmental partners, and so our congressmen, our local state authorities, we went to our state for capital funding and so forth, and our local, so we had our governmental part of our ecosystem. We had our educational part, which was our K through 12, our community college, our tech centers, our four-year schools, and they're part of our educational sector. Then we had the actual manufacturing sector. You know, come to us with your needs. Come to us where you think we might be able to, in this space, help your companies. And then we had the innovative group, whether it be the Siemens Corporation or Lincoln Electric or whoever. And so we got all of our groups together, okay, saying that, look, these $1 million machines, we have a ceramic 3D printer. There's only one in North America, and it's in Youngstown, Ohio, and these guys train on it and so forth. But you know, you can't afford many of those. But we need all of the sectors to be able to learn on it. We need all of the sectors to be able to think about, well, how can that help our company? How can the innovation occur? We have an Air Force base that's 15 miles north of our campus. They're in all the time talking about, well, we have a thing on Tuesday with them, bringing in people talking additive manufacturing from all over the Air Force. So creating that collaborative teamwork because of its efficiency. Then when you do go to your governmental folks and you say to them, hey, we've got all of these people working together. And we're not coming individually for you to all buy us a ceramic 3D printer. And can you help us?
Yeah.
And it's a lot easier for them and a lot easier for you to go back to the folks you represent and say, you know what? We've gotten the pledge from people that they're going to work together so that we're early. And they're not going to try to do it individually, and then we'll fall behind and we'll be too late.
Awesome, it's good work, it's good work. Ben, to you.
Yeah, I think as we've tried to operationalize the technology, we've been really closely partnered with industry and academia through both formal mechanisms like cooperative research and development agreements and more informally. We've seen a lot of benefits come out of that. We're able to expose our future workforce at an influential age to the work we're doing, so we can get some of those folks to come into the Department of Navy. I will say a piece of good news. Within the last year, we've hired a few folks at some of our research centers, 22, 23 years old, and it's amazing to see what they can do in digital design and 3D printing. So places like Youngstown State, the university, they are starting to teach these skills, and we're already starting to see the benefits start to emerge in the service. We also have STEM programs at most of our organizations, whether it be a research lab or a shipyard. And we're trying to incorporate 3D printing in those STEM activities to, again, try to introduce the technology as soon as possible and try to get the future workforce interested. I think going forward, we're going to continue to leverage those industry and academic partnerships when it comes to workforce development. Obviously, that's vital. And as I said before, we can't develop our requirements in a vacuum. We need requirements that industry and academia also recognize so that when our folks transition, they'll able to be as marketable as possible.
Thank you.
I think the government has some pros and cons. We took advantage of the tax cuts by completely amortizing, depreciating a brand new 3D printer from Germany in December 2017. So we were able to depreciate the entire machine in 2017, and it's a big nut. And so the tax cuts really helped us out. And if we're talking about 3D printing in the future for other companies, incentives like that from the government, breaks like that are going to be very helpful. At the same time, the government could be an obstacle in 3D printing. For example, the Air Force with printing metal. So Boeing and GE 3D print metal for their engines and their planes. Right now, the United States Air Force allows no 3D printed parts at all on anything that flies. We're starting to look into it and consider it, but it's going to be a slow process. The reason why, and smartly so, is because there's not really a specification. So we don't want a pilot flying and have something unravel because 3D printing is all made to layers, like it would unravel or unwind. So so the government still is holding back on accepting the technology, unlike the private industry. I think it'll come around, but we're going to have a lot of specifications, and we're going to have a lot of collaboration with industry. industry. So moving forward, I think if we join forces together, I think we'll definitely rise to the occasion and make America just so much of a manufacturing center unlike it's ever seen, without the tool die makers that we've had in my father and grandfather's generation. You don't even have to run a drill press or a milling machine to make something anymore. All you have to do is design on CAD and send it to the 3D printer. So whatever you envision, you can make.
The other huge issue too is intellectual property. A lot of these companies maintain the intellectual property. They don't necessarily make the part anymore for old C-130s at the Youngstown Air Reserve Station. So that is a hornet's nest as far as getting into the defense industrial base and start talking about who's controlling the intellectual property for some of these parts and how do we move forward with that? How do we write contracts into the future to be able to print a part that you designed in your own company out in Kuwait to help tank run again? I mean, any of you who do, you're the military LAs for your bosses, that could be a real sticky situation.
I think we have made some progress with that. I know you're working a lot with the Air Force, and some of the non-stress type parts, they are up there flying, 3D printed. We've got the director of research from the United States Air Force coming in here pretty soon to talk about getting there, because I think they recognize, that we would like to be helpful from that standpoint.
Yeah, just a point of clarification. I won't speak for the Air Force, I have the authority to. But in the Navy, we've flown several 3D printed parts on aircraft, including a flight critical titanium part in the fall of 2016. We have several more metallic parts flown on aircraft this year. It's not as fast or as cost effective as it should be or it will be in the future, but we are able to work that through our technical ways and get those approved, albeit a bit slowly, a bit more slowly than we prefer right now.
And I think it was a good point that just came across between the three of you, that without formal certifications and regulations and understanding those, it's difficult for people to understand where they can and can't use additive because it is different. It's something that didn't exist for 50 years and developed 50 years of regulation. So we have a really fast developing situation here where we can develop those things and help make the industry move.
Can I bring up one thought? This group, I'm sure, may have the question of, well, how do you know if 3D printing would be good for my company or whatever? And it's kind of fun over at our Youngstown Business Incubator. We now have a partnership with an Israeli company that has a software that all you need to do is send the CAD drawing of what it is that you need to create. And it can tell you if it's cost effective, what kinds of volume, what's the timeline and so forth. Should you maybe still be machining it, or should you be injection molding it, or should you be 3D printing it? And so as you start your Whisper campaign back to wherever you're from, and talking about, hey, you guys should be getting involved in 3D printing, and a company wants to know, how do I know if I should be? We do have the answer for that too, from the standpoint of the software design. And so it goes way beyond engineering. The whole software piece can help the understanding and awareness.
Yeah, that's an important point. So there are multiple technologies. 3D printing is not replacing all those. It is another fantastic tool in the toolbox that helps reshape the way manufacturing is done or distributed and making this industry 4.0. Tooling will still exist, but you have to make an intelligent choice. When is that the most economic solution for you, for your particular situation? So in the interest of time, we have one more question, but I'm going to ask you to try to summarize each of you in like 2 sentences, plus or minus. So what happens for us here in America if we don't take action and address the skills gap? Are we too late? Or what's going to be the impact if we don't do more about what we're talking about today? I'll start with you, John.
I think America's always been innovative and a leader and very creative. If you give young people tools, they can draw something on CAD and they can make it. I think we will rise to the occasion.
Okay, Ben?
I think the future of design and production is digital. It's going to be digital files that are made and that drive the mechanism to actually create components. So it's absolutely vital to have a workforce and create those files and run the equipment that produces them. I don't think we're too late. I think the technology is still evolving, and I think based on the great work that's going on today, we're gonna have a workforce that's gonna be able to leverage those capabilities.
And President Tressel.
The only thing I would say is he said the United States has always been the most innovative in the world. If we don't lead the world in the additive manufacturing space, you'll no longer be able to say we've always been the most innovative in the world.
And I would say, to kind of back that up with a little bit of study, so in that A.T. Kearney report, we printed a couple of factoids, and they're on the papers we handed out. And if you look in there, you'll see the different nations of the world who is leading the charge in different areas of additive manufacturing. The U.S. is still at the top. It was one of the first because the initial 3D printers, for example, were developed and commercialized here. But other countries are growing at rapid rates in terms of their adoption, their funding, and their policies. So we don't want to lose that leading edge, and we should do a lot of things to make sure we stay at the front edge. With that, we're not wrapping up quite yet, so we'll open it up for questions. Right here in front row.
Good afternoon, Congressman Ryan, everybody, ladies and gentlemen. My name is Rosemary Segero. I'm a president of Segero's International Group. I'm based here in Washington, D.C., but I'm from Africa. We just came from Brookings, where Congressman Sicily was speaking on leveraging American manufacturing resistance. So this morning, looking at what we just talked here, and thank you so much. I'm also involved with that group that what does manufacturing. Congressman Ryan, I focus on small and medium businesses, small and medium manufacturing, and mostly on global immigrants in manufacturing. That's what I was asking Congressman Sicily. How do we make and bring up, because we have immigrants here, that 80% of immigrants, not the ones that are citizens here, are engineers here in this country. They went to school here, they are citizens. How do we bring them into a space of manufacturing? Because when it comes to there is some restraints, but they were born, some were born here, they live here like me. I did manufacturing when I was in my country, Kenya, but I was doing with the mold with my hands. There was no machine, there was nothing. That's why I focus on manufacturing so much. So how do we make this happen, bring them into manufacturing? Just making America great here in America. They are not going to steal the intellectual properties. They are Americans, they live here. So that's my case with the Congress Sicily, and I'll talk to you about it. I'll give you my card so that we can continue. It's all about collaboration, learning, coordination, and campaign. We are all looking at making America great and looking at that collaboration is international. We cannot just push off international countries, international. So how does that collaboration come in? Looking at what we started here.
Anybody have a comment?
So language is the biggest barrier for immigrants and education. So we have immigrants from Afghanistan, from Syria, from Latin America, South America, Cuba. We've hired all these former refugees from the former Soviet Union. Language is a big obstacle. So really, you need to communicate with design. If you're designing something, there's a lot of integral technical talk. So that's a very big barrier. So English really speaking is the number one obstacle, I think, for immigrants to get involved with this.
Most of them are English speaking. My son
Well,
went
from Kenya, I would agree.
Yeah.
But if you're from Cameroon or something, or from,
we
Ivory
get
Coast,
translators. I work with them most of
French.
them.
So,
All the countries I work with them. So I know.
Okay, so we're going to go to, I want to move to it. I do want to interject one thing. So I work for a pretty progressive company. I mean, HP, I've been in it 3 years. It's fantastic on so many levels. And one of the things that it leads the charge in is diversity. They think about, everybody that we can employ. We're very conscious about it. And Camille, I wanted you to make a comment on that.
I just wanted to actually ask the panelists here, because I think one of the things that I notice in the room, and being a woman in 3D printing and manufacturing and tech, is what I see in the audience is not necessarily represented in leadership across the board in manufacturing. What do you guys think we need to do in terms of diversity, inclusiveness, not just from a gender perspective, but also from a thought process as well? And how would that overall help shape the industry and really give us those competitive advantages?
We hope that the Innovation Center concept, where we're bringing in people while they're younger to understand the opportunities, and to be around people who, I never learned to do carpentry because my father didn't know anything about carpentry, and so I learned to do something else from him. And to get people around to learn those skills, we think it'll be important. We're not really having a problem with the gender side of it. I mean, heck, the number of women in engineering we have, he just hired one of them, Ashley was, one of our best. But we need to do a better job from a diversity standpoint, and I think it has to start younger.
And I think what the President Tressel said about having these centers where you're including people from the art world, it brings a specific skill set with regard to creativity and artistic capabilities, but it's a mindset too. An artist's mindset is slightly different than an engineer's mindset, and I think that can be very beneficial. So that, I think having those spaces are really available. And I just think long-term too, we were talking about pipelines, is having these kind of innovation centers all around the country, because we're moving away from straight K through 12, you're going to community college. We're going to move more towards certifications. And if you're trying to get entrepreneurship going too, people collaborating in these innovation centers, you see with Tech Shop, for example, the old Tech Shop, that there's a lot of patents that came out of that because people were just sitting there collaborating. Someone's on the CNC machine, someone's in the paint shop, someone's in the 3D printer. They start talking, they got a product. One of the products that came out of Tech Shop, that little thing you see on like a cab driver will have, or if you're you run your card, you plug it into your phone, you run it through your card. That was designed at a tech shop. So those are the kind of things that I think can stimulate new thoughts and new products.
Awesome. So we have another question here.
Yeah, could someone comment on the use of 3D printing in home building and possible concerns about displacement of construction jobs when 3D printing can be used for home building?
Not my area of expertise. I can always elaborate on something, but that's not my expertise area. Anyone else? I think that's on a much larger scale than what we're used to. You can imagine homes pretty big, but I mean, it's pretty creative. I personally have a new building going up right outside my house. I'm watching it go up every day, and I think it's not really using 3D printing, but I can envision how you're more deployable in building a structure out in the middle of nowhere using some sort of technology.
So the answer is not quite there yet?
Well, I don't know if it's not quite here. I don't think any of us are probably qualified to say where it is now. So it's a great question. I'm sorry, I don't think we're the right panel to answer it. Sir?
Yeah, my name's Steve Linder. I'm from the OSD office that sponsors 8 of the 14 Manufacturing USA Institutes, and also a 1973 graduate of Youngstown State University. And I just want to say that this has really been a very good panel here. I mean, education and workforce development is one of the key underpinnings of all of the institutes that are funded by the government. And in fact, I think first week in August, the government EWD team is actually meeting at America Makes to talk about what is going on across the Manufacturing USA Institutes. Through the graciousness of some additional funding from Congress, OSD has another almost $30 million to put forward to manufacturing education. We are putting together a comprehensive plan right now of how we would like to spend that money. I know if we were invited to come over to talk with you, we'd be more than happy to give you an idea of how we would like to use that money. But no, EWD is certainly a key thing. We need to have the skills and the talents of the people to be able to do all these advanced manufacturing technologies.
Great. Jason, right there, my staff.
Yeah, and I just wanted to say as well on our end, if there's any questions that we haven't answered or you want to do a deep dive on some of those, where are the opportunities, you can reach out to Kasia and our government team as well. And we can set up some follow-on sessions where we can go into some others and maybe turn this into a wonderful series where we come back and visit again.
How about one more question, and then I think we're probably going to have to go. I guess. You're standing. You've had to stand the whole time.
No, this has been really interesting. Thank you guys for all your insight. And I'm a big fan of advanced manufacturing. I've spent our AM. I'm a fellow from National Lab. I've spent 20 years in machine shop, prototype machine shop, ones and twosies, specialized stuff, with guys that are both the old tool and die makers and the old school machinists, and a lot of the new up-and-comers coming out of apprenticeship programs with digital toolboxes. But to the comment earlier on language, manufacturing has a language. It's an international standard, GD&T, and it's on every drawing, and that's what dictates form, fit, and function. And I think when you talk about AM and you talk about training being far ahead on that curve, I think there's a tendency we've got to not get too far ahead, because we got to make sure that these new people doing things on CAD understand really microns, tolerances, and I think that element it's small, but the devil's in the details when when you're putting people out of just because you see it on a 3D model doesn't mean it's going to work. And I think you got to make sure we don't jump too far ahead. That's just my take on being around this environment for a long time. So.
Well, thank you for that. Look, I really appreciate everybody being here. I realize this is your lunch hour. A lot of you probably have to run right out. There's a few more questions I know. A few of us are going to be around for a few more minutes. We're more than happy to hang out here. We have the room actually until the half hour. Please, anybody who had a question, feel free to come up and ask us. Congressman Ryan, do you have anything to say? Thank you.